Hello. Is everybody excited for lunch?
And for your talk.
Thanks, Sarah. So I'm here today to talk to you about building a tiny gallery. But first, I'm going to tell you a little bit about myself in case you don't know who I am. I mean, I don't know who you are, but we don't have time for all of you to tell me that, and I'm on stage, so you have to listen to me. Hi, I'm Rachel White. I'm a technical evangelist at Microsoft. I'm OHO on Twitter. I'm also the co-chair of the Node.js Community Committee, where we work on initiatives that are important for, you guessed it, the community, so all of you, hopefully. And this touches on stuff like educational outreach, diversity and inclusivity work, internationalization efforts, and a ton more. I'm also a programmer, obviously. I'm also an artist and a maker. I basically have entirely too many hobbies, and I try and incorporate all of them into what I do, which is probably going to make this a little bit different of a talk since I don't write production code, so I can use whatever I want, which is kind of great. So to start this off, I'd like to talk to you about some of my previous projects to give you a better idea of, the kind of things that I like to make. And to give a better idea of who I am through my code. So, RoboKitty was my first Node.js and my first hardware project that I worked on in 2015. It was also my first conference talk, because apparently I like to overachieve. So for this project, I use a particle photon. It was connected to a continuous servo that I glued to the dispenser handle of a cereal dispenser. The way that you activated the sensor was via a Node app on the same network as the photon. So basically, you would go to the website. There was a button that said feed. I was using, I think, a really poorly written cron job to even automate it. So basically, you could sit in your house, go on this website if you didn't want to get up 5 feet, push a button, and it would dispense food for the cats. So in theory, it's extremely simple to build. It was super simple. It's a microcontroller, a servo, and a Node.js app running locally. But the talk that I gave on it detailed the struggles that I encountered when trying something new. I had no idea what I was doing, so I just did whatever I could to get it to work, which is pretty much all that I do with everything. And I also made sure that when I was building this project, I wrote an extremely verbose README so that anybody who wanted to get started with the project could follow along, whether or not they had ever written a line of code before. So this was actually, surprisingly, my most successful project so far, and it has I think 760 stars on GitHub because a bunch of people wanted to try it out because cats really sell things. The next project that I wanted to show you is a Twitter bot that I made called Magical and Cute. It's currently offline, so don't try it because it won't work. I containerized it and it broke, so that's a different talk, I guess. So Magical and Cute is an app that uses Twit, which is a Twitter client for Node. It's an API client for Node. It also uses Microsoft's Face API. And when people tweet selfies at the bot, it would ping the Face API, which then returns an object full of XY coordinates of landmarks on the face. I think there's 28. That's a guess. Could be wrong. And then using graphics magic, which I will never use ever again, I iterate through the eyes, cheeks, the lips with some custom cute little animal ears and cheeks and noses that I drew, and then it tweets it back at the person. I did this project for a couple of reasons. One, people are super into Twitter. I mean, especially Node people. Twitter is where the majority of the social network discussions happen with Node, so I was like, hey, this is a good place. And plus, Twitter bots are just fun. But more importantly, people are afraid of facial recognition, justifiably so. So I wanted to teach people to understand how some facial recognition APIs work, while also teaching you how to make your own Twitter bot. The barrier to a lot of things, I feel, when I'm teaching people things is fear. So either fear because they are intimidated by something that they've never tried before, fear because they don't understand something. So I always try and explain things as best as I can to educate them so that they won't be afraid to try. And the last thing that I'm going to tell you about before we get to the meaty, important part of today's talk is an art series that I'm working on called New Romance. So, this looks so weird. New Romance is a project that is visualizing what modern cybernetic augmentation would look like through modern hardware and special effects makeup. I did everything here. I molded and casted and painted my hand in silicone. I did the nails, obviously. I soldered that NeoPixel ring, I programmed it, I literally did everything. And the whole purpose of the series is to partner with underrepresented people who have their own views of what cyberpunk is and what is body autonomy, and help them create a more cybernetic version of their own future. And so this is the first piece in the series, and it deals with the need to be constantly logged on to social media. It's monitoring Twitter for the use of a certain hashtag, and when somebody uses it, that little NeoPixel ring changes colors to notify the person that someone has been talking about them online. The reason that I think this is really cool is because all of the hardware is written in Node. When people who have done hardware in an art setting come up to me and talk to me when they see me exhibiting these pieces, which is usually in typically non-technical settings, they're usually super shocked that I wrote Node for this instead of plain C or C++, and I don't know C or C++, so I don't have any other options. So by doing interesting art like this, it allows me to teach more people that maybe never would have heard about Node or Node bots, and that's honestly like one of my favorite things to do. So hopefully it's obvious by those 3 projects what my intentions were and are when it comes to working on projects that I'm going to release out into the community. I don't necessarily tend to focus on building libraries that people can use. It's for the best. Sorry. I don't really contribute to core, although I've made a couple PRs at Code and Learns. I just really like to pick interesting and engaging projects that take Node and some other rad stuff that people have made and already built and be able to create a fun story around it to educate and entertain people. So I like to talk about the mistakes that I made, the things that I could have done differently or better after the project is done, because that whole process is extremely important to me when it comes to humanizing us as developers. I really don't like it. Well, I mean, we don't write perfect code the first time. If you do, you're lying. On this same subject, I gave a keynote at Node Interactive a few weeks ago about how creative coding is the best way, in my opinion, to bring new people from other languages or who are totally new to programming into Node, because it's easier for people to relate to a fun project than it might necessarily be for them to relate to a real-world implementation if they're not familiar with the way that our front and back-end processes work. So yeah, that's what I like to do. So today, we're talking about this. This is the tiny gallery. So I decided to make a pixel art gallery for you to keep in your home. I also wanted to utilize some really rad features of Azure, which we'll talk about in a little bit. And I also wanted users to be able to upload their own images to be able to display those. I needed it to be semi-secure, but I'm not too great with security stuff, so I wanted to at least try and protect it a little bit from any kind of code injection through the file upload process. So I'll explain to you what I did, and if I'm wrong, you can tell me later, but it's open source, so you can fix it for me. Originally, I wanted it to be live pixel art drawing, but like drawing on the canvas on a website and having it update real time on that LED matrix, but I didn't want to deal with iterating over all of the currently active pixels because I'm lazy, so it's a good bullet point. So let's talk about the hardware. For the hardware, I used a Raspberry Pi 3 Model B. I had only worked with a Raspberry Pi once previously, and it was for an internal hackathon at Microsoft, and it was in Python, and it was the same day that I ever wrote Python, and then I was like, this is really easy, cool. I was super intimidated because the idea of needing a keyboard and a mouse and like a router to like hook all this stuff up was too many steps, and I'm lazy, so I didn't do it. But luckily I found Pi Bakery, and if you're familiar with Pi Bakery, it's this really awesome application that lets you put your SD card that you're gonna have your OS running on the Raspberry Pi into your computer, and it lets you provision it before you even plug it into the Pi. So you're able to choose what like distro of the OS you want, if you want to run the Lite version, if you want to change the default username and password, if you want to set up the Wi-Fi beforehand, and if you wanted to set up being able to use VNC to get onto the Pi, which is what I've been doing. It's really great. It's easy to use. If you haven't used it, try it out. The other thing that we're using is this 32 by 32 LED matrix panel. I got mine from Adafruit, and these can be daisy-chained into larger panels, which is really rad. This is essentially like a smaller version of the ridiculous billboards that you would see in Times Square, so like this times 1,000 or so, only doing one. So luckily, I know some people are intimidated by hardware, but the hardware of this project is the easiest part. The panel itself requires a 5-volt power supply, so the only soldering that you have to do is attaching the right kind of adapter to your power supply. I think I only had to solder like 2 points, which are these leads, into the 5-volt adapter. For powering the LEDs, a single chain needs 13 I/O lines, which fit all in the header of the old Raspberry Pis, but since we're using the new one, the new Raspberry Pis have 40 pins, so there's more GPIO, which allows you to connect actually 3 parallel chains of the RGB panels if you want. But for today, we're just dealing with one. So we're gonna start out with talking about the Pi app, because it's the worst part of the code. Obviously, it's a Node app, otherwise I wouldn't be up here talking to you. It's also a testament to why I shouldn't write production code. I definitely would probably be responsible for a lot of the like IoT botnet stuff if this was my full-time job. Luckily, it's not. But in reality, I just really love to write fun, lazy code that gets the job done because it's still the same end game, and plus you can always fix it later. So since the Raspberry Pi is the one that's powering the matrix, we have to write some stuff that runs the panel. But there's a problem. There's not really a Node library for the LED matrix. There's a few, but they're pretty out of date. They're not that great. So I did something that's probably going to offend some of you. I took this C++ library, and I'm making calls to it using a package called node-command, CMD. It allows you to use simple command line or terminal interfaces to run CLI-based style commands as if you were in the terminal. So basically what I'm doing is, for the Raspberry Pi side of the app, I'm listening to the calls coming in from Microsoft's IoT Hub, and when it knows the image that's being sent, it grabs it, it saves it locally, and then I'm concatenating. I'm saving it, despite whatever the file name is, I'm saving it locally with a generic name, and then I'm running the command line for the C++ library from Node, so it displays it. It works. It's best that I could do with what we had. So the way that I'm handling the files and passing them around makes me comfortable with running things that way because there's nothing that's being sent over the IoT Hub or being pulled down from the file storage that has the original name or is controllable by the user, so I'm not able to like get anybody naming anything funky that's gonna crash the Pi yet. Nobody's used it but me, so we'll see. It was fun to figure out. I thought it was pretty good at least. And then there's also a web app part of the application, also written in Node.js. I'm using Socket.io for the real-time communication between the images and the file upload and the calls to the IoT Hub. I'm using Express for the routing, EJS for the templating, and jQuery because nobody tells me what to do, and I can. There's a little bit more going on under the hood, but we'll talk about that when we get to the code. So another huge part of this project is reliant on some really great Azure services that I'm going to give you a brief overview of. We're using the IoT Hub, the file service, and the web app service on Azure. So, excuse me. Azure's IoT Hub, we're using it for communication between the web app and the Raspberry Pi. When an image is selected from the gallery, it pings the IoT Hub, which notifies the Raspberry Pi that there's an image ready to pull down from the storage and display. Because when you hit the file upload form on the web application, it's not only doing all the Socket.io stuff, it's also uploading it to file storage. And IoT Hub allows you to have bidirectional communication between devices, which is really great if you have like an array of devices that you need to communicate with each other in certain ways. It also allows for a more secure connection as each device is authenticated with the system. So when the hub is getting messages from me, it knows it's me and not some random other Raspberry Pi that might be in my house. The Azure portal also helps out immensely with metrics visualizations so that I'm able to see really quickly if I'm having any kind of communication errors. And the free tier has up to 8,000 messages a day, which is more than enough for most people to have hobby projects like this one that I'm showing you today. So Azure File Storage is what we're using for all of the pixel art. It's simple, secure, fully managed cloud file shares. It uses SMB and HTTPS. It supports different types of shares based on your needs, so whether or not it's structured or unstructured data. We're using blob storage because it's just images and I don't need any kind of tabling or anything like that. And the best part is that there's a Node SDK, which makes interacting with it a hell of a lot easier, and it makes my life easier, and I like things that are easy. So finally, we're hosting it on Azure's web app platform, which supports Windows and Linux platforms. The best part of this web app service is honestly the ease of integration for continuous deployment with a lot of your favorite services. So basically, all that I have to do is authenticate and sync my GitHub account and repository of choice, just like any other kind of like continuous CI/CD stuff. As soon as I push up to master, it redeploys automatically on Azure. And just like IoT Hub had some really great monitoring, the web app does as well, which is really great when I push bugs, which I do a lot, and need a quicker way to monitor the health of what I'm working on. And the free tier is also pretty great. It supports up to 10 apps and 1 gig of disk space, which is pretty rad. So those are all of like the technical parts of what this application is. And now it's time for fun code and demo time. Please do not judge. All right, so I'm gonna drag this down here and make it bigger for you. All right, so this is unrefactored. All right, so basically this is the app that's running on the web server. I have my .environment stuff because there's some things that Azure needs that are different from it if I would be running it on the local host. These are all my IoT Hub variables, and then some simple, standard FS Express. I'm using Molter to handle all of the form uploads. And Blob Service allows me to upload my images to Azure's file share. So what I'm doing is I'm just having the server listen to the port that I define, which is 3000 locally or whatever Azure's default port is when we're loading. And when you hit the standard public site, it's saying, hey, use Express. And the first thing that I'm doing when you land on that page is I'm making a call to Blob Service to get a list of the files that are currently there. Azure's Blob Service allows you to host things, so you don't need a kind of like shared access key if you're using a different kind of file share. So since it knows that connection is being made from a place that I'm authenticating it, it'll allow me to render those images over to EJS and display them on my single page application, which I'm doing by passing in the images there. And then I'm opening the IoT client. So what's happening is on the site, when you are either choosing an art piece that's already uploaded, it notifies Socket.io, sends it over to IoT Hub with the string of the name, and then sends it over to the Raspberry Pi. And by having the string of the name, it knows where to grab it from Azure's file storage. So this is handling, the form uploads. I'm using Molter, saving it locally with a temp-generated file name, and then sending it up to Blob Service, checking to see if the container that I defined exists. If it doesn't, it makes it and puts it there. If it is there, it still just adds it, doing a little bit of positive affirmations in my code by completing it. And then, so the Raspberry Pi, I warned you. This is what I'm doing here. It's also listening to the IoT stuff. I'm using another package called Image Downloader, which makes it so I don't have to do any of the encoding stuff myself, because lazy. Yeah, so you come down and it connects. It tells you when it's connected. It listens for the call to come in from the IoT Hub, and what it does is it saves it to just being called active image. So I rewrite it at the beginning of each call. And then this is the command line call for the Raspberry Pi RGB LED matrix gallery. It has a couple different utilities, because you can either just display images like regular JPEGs that don't have any kind of animation stuff, but I want to do GIFs. So I'm using the utilities for LED image viewer, and then the T2 flag allows me to display it for 2 seconds, and then I'm passing in the path to the image that's being downloaded from the server. And then that's it. It's super simple, and I wanted to show you how the Raspberry Pi gallery thing works as well. So this is our Pi RGB LED matrix. It's really actually like the most robust RGB LED matrix library that's out there. It has a ton of documentation, which is fantastic. It tells you information if you want to chain together some of that stuff. It's great. Check it out if this is something that you are considering doing. But now I guess I should probably show you how it works, because that's really what everybody cares about. Cool. So this is the tiny gallery. I'll make it a little bigger. This is the URL for the GitHub if you want to check it out or fix anything. It's github.com/RachelNicole/PiGallery. And then, so basically what happens is I have these little images down here. I don't know which way is up, but I will hold it up. And which one should we pick? How about the donut? I'm currently tethered to my iPhone, so let's hope it works. It probably won't be as real time as if I was on the network Wi-Fi, but you click the little donut. Oh, wait, I have to run the code on the Pi. Duh. I never learn. I'll show you how it works, because I have VNC up here running. So yeah, this is the structure that I have. That is really small. Well, I know what the file is, so let's just, oh no! Live debugging, give me a second. All right, I'm gonna close that connection. The Raspberry Pi is not on. That would be a problem. All right, so I had to plug it back in because it disconnected, but as soon as it connects back to my network, I should know. It says I have 2 tethered devices. I'm gonna reconnect, connecting to the IP address that I'm not gonna tell you because the password's default. The Pi's probably still booting up. Okay, we are connected to my iPhone. How's everybody doing? Okay, cool, we're good. All right, so here's my, I love that I don't refactor code, but I go through the time of setting a wallpaper on my Raspberry Pi. All right, so let's see how good my eyes are. Nope, CD, desktop, CD, matrix, CD, node, Pi, node, index.js. And then we want it to say client connected, because that'll mean it'll be able to get messages from the IoT Hub. It's probably going to take a couple seconds. Cool. All right, so we're connected now. Hooray. I'm going to refresh this. Please don't go to this website. All right, so tiny gallery, donut. Come on. Oh, the page? I can also check and see if I have any errors. Oh, it should be working. I think it's probably just the network connection, so let's try one more time. Donut.
Yes.
Did it display? Oh, it said a red line? Oh no! Every time I do hardware demos, I'm like, I'm never doing that again. Because this happens every single time. All right, so I know that this is working. Let me make sure all my pins are in here. Nothing's bad. These are all good. You worked before. Why are you being bad? All right, one more time. If it doesn't work now, I can just like show you later. I'll unplug, plug back in. This is bad. Of course it doesn't work when I have to show like 300 people. Okay. Yeah, it's nervous. Okay, I'm just checking the connections, unplugging, plugging back in. Let's redo the VNC one more time. And go back up. Client connected, we're good. That refreshed. Oh no. Okay, well guess what? It's not gonna work. How about the pie? No? Okay, so, well, good thing I have pictures of it working, and then I can work on it and like show you later. So let's just watch this one a couple more times. This is how it works. I swear it works. Basically, now this talk is about failure. Honestly, though, like, you get the point, right? Cool. So it was fun. Like I said, my name's Rachel White. My name on Twitter is Oho. If you're interested in the community committee, please come talk to me later. If you're interested in seeing it work, please come talk to me later. The code for the gallery is github.com/RachelNicole/PieGallery. Smiley face. Thanks.